All right, good afternoon, everybody, and thanks for joining us today. We're going to be speaking with Tony Cupido. Sorry, I apologize, Cupido today.
Cupido. Yeah, that's good.
Okay, he's going to be our special guest speaker today, and he's going to be discussing the Joyce Centre for Partnership and Innovation, which is a new net zero emissions building at Mohawk College. He's going to be discussing its construction and the special leading edge technologies that have been incorporated into the building to keep its operating costs at well below that of a traditionally constructed building. Before we get started, just a few housekeeping notes before we get going. We are muting our phone lines today to keep background noise down during the presentation. If you do have any questions, comments, anything, we'll keep an eye on our chat window. And we'll of course take a look at our questions window as well. We're going to keep questions to the end, but we should definitely have time to go through and answer any questions that we've got at the end of the presentation. And we'll unmute the lines at that point too to hopefully get some further questions. So without any further ado, I'm going to hand it over to Tony, and we'll get his presentation up here really quick.
All right, thank you, Julie. Thank you, everyone, for joining in on the webinar and having the opportunity for me to speak to everyone about a wonderful building we have here in Hamilton, Ontario at Mohawk College, Joyce Centre for Partnership and Innovation. And my objective today is just to highlight the building today, what's in it, some of the details about it, some of the demographics, talk to you about some specific features of the building that make it net zero. Originally it was net zero energy, and now we're zero carbon certification, so we'll talk about that. And then talk about some of the challenges that we had perhaps in the building, as any construction project would have. And then I'll highlight some of the costing issues. Costing's always appeared to be a barrier for low emissions buildings, but I think we'll surprise you with some of our findings in this particular building. So just to give everyone a sense of this, if you're not familiar with our campus, we're up on what's affectionately called the Hamilton Mountain. We're a college of approximately 15,000 students. We have about 1 million square feet at our Fennell Avenue campus, and then some in Stony Creek. But this particular building was a part of a federal grant. It's called the Strategic Infrastructure Fund, and it came from the federal government. Came out about 3 years or so ago. We were very fortunate to receive a grant of $20 million from the federal government for a planned facility of $50 million. There were some renovations that had to be done in an adjacent building that we connected to, but the new building was $50 million, $20 million received from the federal government. And what was important is the early numbers for construction were $47 million, and then, of course, $3 million for soft costs, engineering and architecture. The estimated size of that building when we put in our application was around 90,000 square feet, and that came out to roughly about $525 a square foot, which made sense to us when we made our application. To make up the difference in the building costs, we were very fortunate to have the Joyce Family Foundation, Ron Joyce of Tim Hortons fame. The Family Foundation were very kind to give us $5 million. And we also received funding from the Student Union of $1 million. ArcelorMittal DeFasco also gave us $1 million. And the Marinucci Family Foundation also gave us $500,000. So just from donations and grants, we were well over half of our building costs, and that helped us with the momentum to get this going. Just a little bit of a plug, we're very fortunate to have a number of design awards, and most recently the Royal Architects Institute of Canada awarded us Award of Excellence for Innovation in Architecture. That was just announced a couple of weeks ago and will be presented sometime this fall. We're very proud of that. Many of the features or awards that you see there relate to more of the energy piece and something along the lines of sustainability. But for architecture, it's also a very attractive building, and very, very happy that we were able to win that award. And the architect, MSA Architects, along with B&H, were our local firms. MSA is a local firm here in Hamilton. The other important relationship here is that Mohawk College is a partner with the Canada Green Building Council, and we are part of a zero carbon building initiative. We're one of 16 pilot projects that the Canada Green Building Council initiated, and we've earlier last year we became the first institution to get a zero carbon building design certification, and we're currently working on our performance certification. You need roughly a year's worth of data or so to get a performance certification, and we're well underway to getting the data that we need, and I'll talk a little bit about that. This just gives you a perspective. We're looking south, high above a hospital that's across the street, looking onto the Fennel campus, and you can see a rendering of the building right in the center of that picture. And the reason I wanted this slide on here is to give you the sense of scale and magnitude of how it fits onto the campus. And as well, buildings that for you would be up in the top left corner are additional buildings that were important for some of the infrastructure that was needed for the building, and I'll show you a little bit later how that came into play. So we're looking south onto the campus, and you can see the prominence of two major solar panel structural supports that make up a bit of the iconic image of this building, and you can see them plainly there. We'll have some pictures shortly. I just wanted to touch on what's in the building to give you a sense of the scale of this. We have on the what we call our level 0, or roughly ground level, 200-seat lecture theater that rises up to the second level, a 150-seat lecture theater which goes down below this, and then a 100-seat classroom. So about half our capacity for this building is on this particular floor. And we also have a very large gallery area that's and a feature stair. That area has been home to a number of conferences, presentations, or otherwise over the last little while. Again, this building opened up in September of 2018, and we've now wound down 2 full sessions, or sorry, fall and spring and winter sessions that have taken place. And we're now into the summer months, and there's still lots of activity that's going on, but it's certainly not full. The first level has the upper level of that 200-seat lecture theater, which I showed you. We also have what's called a digital creativity center for people of a certain age and vintage. That's effectively known as a library, but today it's filled with technology, and it's an impressive facility right now with a number of different opportunities and displays that students can work on in there. It's a much different thing. There's probably not a book in that entire area, but it's filled with technology, including 3D printers that students are using on a regular basis. There's level 2 and 3 are very similar. They have 4 major labs on each floor, but just to give you a sense of this, Mohawk is known for much of our digital health technologies, and we have an experienced testing lab in here where we're working with different individuals who will have monitors and systems on them that will help monitor their daily health activities and rhythms and heartbeats and blood pressures and everything else. And we're seeing how that actually works with 3D monitoring and reviews. That's kind of an interesting opportunity. We also have an energy and power management lab, which is something that will be utilized for students who will be looking at this particular building, and someday with the right oversight will take over the control of the building. So they'll be monitoring the systems in there, and they'll have the autonomy and the authority to make minor changes and set points and that for students. So that's an important area for us. Clean and renewable energy, where we have some solar panel technologies in there, where we're teaching students how that activity is harnessed and how systems work in there, including inverters and that, and they get testing experience on how that works. And a sustainable design lab is also very similar, where we have activities where students are learning about different technologies within the building and in sustainability in general. We have vendors who come in and help with display of different products and helping enhance student learning. Level 3, we have an avionics lab. It was a bit of an odd fit at the early stages here, but that lab will be moving out in about a year. We've secured a major contract with a large airline vendor, and up at the Hamilton Airport, and that lab will be moved there. We have one of the largest avionics testing labs in Canada, working with the federal government, and we're very proud of that. But it was just an initial home until this new center is built, not too far from where we are right now. Physics and metrology is a testing area for measurement, and we have some very highly sophisticated products in there and material and equipment that helps students do measuring down to a millionth of an inch if we're going back to all imperial units. Cybersecurity is one of our growing areas. We just put it in as a minority component here. We're actually, one of the key things is we're actually teaching students how to create viruses and attack systems. And the reason we're doing that is by understanding how that happens, they can learn the defense to that, so they can work with companies to help with the defense of those particular systems. It's kind of interesting to go in there. Advanced Technology Lab, we have a number of companies that have set up shop in there, are working on various projects with some researchers. Kind of an interesting place to go, and I've been involved in some of that myself. And then we have a partnering studio. We have an area where companies can come in, provide seminars to students and researchers, and also have direct interaction for interviews and other things. It's a neat space and lots of activity in there. Level 4 was, for the most part, shelled, and we have activity planned for there soon. But we also have the Center for Climate Change Management, which is a big piece for Mohawk College. And just to give you a sense of scale, that was one of the, there's a patio out there as well that eventually will be used for different functions. I wanted to show you the penthouse because this is an important piece. The mechanical penthouse, which includes the electrical room, is less than 3,500 square feet. Actually, it's less than 3,400 square feet. But I wanted you to understand that particular size. I'll reference that in a little while. And then underneath the large supports for the area, which has been properly enclosed, and students can actually go out there, check the structural components, look at the solar panels very closely, look at the inverters, do testing and everything else on there. So I wanted to give you that perspective. This is the finished product, and architects do a great job of hiring photographers that can take great pictures, but you get a sense of the scale, get a sense of the supports for the solar panels, and some of the window to insulated concrete panel ratios there. The ratio for us was roughly 35 glazing, 65 panels. In this particular shot from this angle, you see a lot of glazing. There's also some spandrel panel glass sections that give the appearance of glass, but also are heavily insulated to help out with the R values. There's another view of that from looking from the west, looking east, and you can get a sense of the structures there and the patio setups that are up. Very nice look and functionality as well. This isn't a shot inside. There's a gallery area I mentioned. This is just outside the 200-seat lecture theater, so you get a sense of scale, lighting, configuration, and we're very pleased with how this has come about. Another view from that, looking down at the feature stair, and giving you a sense of scale as well. There's also a very large light well that goes from the ground level where that individual is walking down in the lower center right up to the fourth floor. So it gives you a tremendous amount of light that comes in and highlights the rooms that are adjacent to that. The kind of in the band in the middle of the picture there, you can see and lounge chairs. That's the Digital Creativity Center and typical student activity in there. It's been quite a popular place. Just wanted to pop up the mechanical penthouse area. Wanted to give you a sense. And I haven't really talked about the demographics of this, but this building has a variable refrigerant flow geo-exchange system. It's a correct term. So we have a variety of geothermal wells. There's 28 geothermal wells that go into the building. I'll show you a schematic of that. 4 rows of 7. And in the mechanical penthouse, we have a heat pump system supplied by Dakin, a popular brand. And the combination of the heat pumps and the geothermal wells, we've been able to cool and heat this building with efficiency. And over almost to a year now, we've had virtually no maintenance calls on any of these products. So that's an important piece to us. The item that's the piece of equipment that's just on the left center of your page here is called a I'll get it in a minute. Templifier. Sorry, I lost track of that. My apologies. A templifier. It's made by Dakin. One of the challenges we have is the vestibule area. So heat pump systems are very good. They're very produce sufficiently hot water or heated solution to give you the right heat temperatures in the vestibule. So this templifier is in effect an electric compressor that helps boost that temperature for those vestibules, and as well as domestic hot water. I'll talk about that in a second if needed, and boost it up to about 60, 65 degrees C. We do have a solar thermal panel system in here, which provides all the hot water we need for domestic purposes, and for the most part, that's worked well. We did have a rough winter. People are familiar with Southern Ontario. We had a lot of freezing rain. There were challenges, and that's when this templifier did help boost some of the domestic hot water temperatures as needed. This is a close-up of the Dakin system. There are, again, I may have mentioned 32 of these individual units. They're ganged and zoned to different areas within the building. We did leave reasonable access for students to come in and check these and do some testing if necessary. This is another view looking, for people familiar, looking north here, but you'll see at the end of the room, there's the heat panels and then circulating pumps. I also left this picture for an interesting piece. There was a heat exchanger that was proposed for the air handling system. There's only one air handling system for the entire building, and it has, we do capture and use reclaimed heat in the building through an enthalpy wheel that's in the air handling unit. And but the designers had a heat exchanger proposed there. If people see my cursor, there were ports that were at the top of this, at the bottom, that would connect to the air handling system, which is somewhere right about here. But at the end of the day, they felt they didn't need it, but it got installed. So when I'm touring people through there, I just say it's a piece of architectural art that was designed into the facility, and people get a kick out of that. This is the roof area I mentioned that's safe for individuals to go up to. This was taken a little bit of time ago, but you can see you can have safe passage through and underneath here to see the structure. There's inverters here for the solar panels. You can get close proximity to the panels and check some of that out. We felt this was an important space for students to do some learning and firsthand view. And it makes for anybody who has toured, who's perhaps on this webinar or has an interest in touring this facility, this makes an excellent venue to bring people up when the weather is appropriate. You get a good view of our campus and a good view of some other things as well. We had a Chinese delegation here on Monday, and they love this particular space and the opportunity to get up there. This is another view of that taken on a sunnier day. You get a sense of the activity that students can appreciate and the scale and the sense of how that was designed. Another view of that looking down onto a patio level. And again, these spaces are becoming very functional for us, and we're appreciative of the architecture that happened here. Now, just to give you a sense of more so on the design strategy, these are 5 bullet points that are critical for anyone who's contemplating a net zero energy building or a zero carbon building. You need a very, very strong building envelope, very tight envelope, as high an R value as you could possibly achieve within reason. And you have to have a very well-defined glazing to panel ratio. That's typically 35, 65. You can't venture too far from that because, as everyone knows, glazing is as beautiful as it looks. And we had triple pane glass. I'll show you a picture of that. Even the R value of a triple pane assembly is still, roughly R7.5 or so. You do need solar PV. I'm not sure you could do without that unless you have unique circumstances. And in our case, solar thermal was very efficiently applied and cost effectively applied as well. But there were some challenges. Typically for PV, I'll show you that soon, very difficult to have sufficient roof space to manage the entire array that you need for a net zero building. You typically need more space. We couldn't put it on the ground. We had to use other roofs. I'll show you that in a second. Mechanical systems with rainwater harvesting, very important that you have an efficient design. We went through a number of design scenarios, what we call an energy budget, looked at different systems and how that would come out. But you do need a very efficient and cost-effective design, and I'll talk about that in a second as well. Measurement and verification. You need to have good commissioning, and it's essential on any building, I think, but certainly for net zero building, where metering and outputs and data and consumption and production issues are more important than ever. You need to have that in place, and you must ensure that you have that set up well in advance of the need to do it. Change. We've been working closely with our students to have them better understand what a net zero building is. This wasn't an opportunity to come in and do what they've done many times, and that's come in and sit down and just plug in your phone or plug in your computer or whatever. That digital creativity center I showed you, we purposefully put very few electrical outlets in there to have the students think much differently about how they use their laptop and phone, and for the most part, that's worked very well. There are some challenges that go with that, maybe in some of the labs I might highlight, but for the most part, you have to work on changing the culture of your occupants. For us, it's some staff, but primarily students. We also had a student team called Zero Carbon Ambassadors that helped work with students at the start of each term, to work with them to help better understand the building and how it works, and to have them embrace the need to be a little bit more thrifty on their energy consumption. Here's the triple pane glass. We were very fortunate this came out of the Sarnia area, but we also had purpose I wanted to put in here just to give you a sense of the scale of each larger pane, but we had a ceramic architectural frit that was put into the each assembly, and that had two purposes primarily. One was to help with some solar reflectivity, up to about 5%, which may be helpful. We're going to do some studies and research on that. The other thing is it did give some relief from just plain glass, and that helps with not only humans who can bump into that, and I've done that on different occasions sometimes in different buildings, but certainly for birds and people from outside, it gives a much better architectural relief. This is a picture I took, but this is a precast insulated panel out of a company that came out of just outside of Mississauga. And it's not a sophisticated unit. A precast insulated panel has basically some mortar cement mixture on both sides of an insulated panel insulation, and that has to be a lot of the so that somehow that has to match up to the gaskets and the other fitting pieces that go around. And we had to be very careful with how that was done. There was lots of detailing and sizing and mastics and caulking that had to be used to make all that work properly. So we started with a little bit of a template on the first couple of assemblies to make sure we had it right, and did some early testing on that. And we were happy with what it worked out to be, and that product. Like we did do an air leakage test at the end while I'm thinking about it. Right, we did do an air leakage test, and we were just shy, and I mean just shy, of passive house standards. So this is a very tight building envelope system, and it needs to be if you're hoping to achieve net zero energy or zero carbon. The arrays and the panels, and I have some pictures to support this, but this is our new building where my cursor is going through. I think you can see that. That's the new building, somewhat to scale, but we had to put additional panels on the buildings to help with the total output. So roughly a third went on to the new building, and roughly 2/3 went on adjacent buildings. the most easterly two, this one where my cursor is, and this building here, which affectionately is J-wing and A-wing. We could not run cable back to the main building. It was a little bit challenging from a DC perspective, so we net metered that production into the electrical room that's in the J-wing building. This is known as H-wing, and we just ran a cable from here along the E-wing roof and into the new building. So just shy of 2,000 panels. Canadian Solar was the company that provided the panels. Excellent quality product. We're happy with it, but this is providing us 500 kilowatts AC power peak, roughly 653 kilowatts DC power. This is a picture that gives you a sense, or pictures that give you a sense of that. So here's a pretty good scale size of all the structure and the scaffolding that was needed to do this. Lots of challenges with doing this, but it worked out very, very well for us. Here are the neighboring buildings where my cursor is. So your bottom right, this was the J-wing, this was the A-wing, and this is the start of the H-wing. So you can see the adjacent buildings. We did have to do some re-roofing on the A-wing. We used deferred maintenance dollars outside of the contract. So we had to coordinate that, and that was actually done about a year and a half before the building even opened. So there's lots of coordination that goes with these projects on a campus, but it gives you the sense of scale of all of these here. And for the most part, we had very few issues with doing this. Here are there's 5 solar thermal panels. They're Viessmann panels that for our domestic hot water, and they have worked generally very, very well. They do have some safety features on there. One of the challenges with solar thermal often has been overheating. These panels have a kind of a gauge or an automatic shutoff that helps limit the ability for. We do use food-grade glycol mixture for this, and if they overheat, it creates a lot of complications with some of the systems. This gives you I wanted to give you a sense of the schematic of our new building in relationship to where the geothermal wells went. So our new building here, where my cursor is, you can see that. Because of the staging area right here where my cursor is circling right now, this is where all the trailers and laydown space was. Just went next door, literally about 30 feet away, to put down 28 wells down almost 600 feet. And in this Hamilton area up in the mountain, it's in shale rock, so you go down about 10 feet below ground level and you're into shale. So these are down quite a way. So we're creating a large mass of warm rock, which for the most part easily supplied the heating that we needed for this winter, and we had very few, if any, issues at all. So this gives you a sense as well that we have, there's condenser units that are in, evaporator units, they're called, in each classroom and lab area, and then we have the heat pump in the mechanical room here. We do have some availability for handling additional heat if that was necessary. We did that, if you're familiar with the term, a bit of a ground slinky system on the ground source heat, or ground source wells, where we have the ability to arrange to overheat the well area. That can be a problem, so we have ways of dissipating heat if we need to. That's something we'll probably need to monitor closely over the next year or two. But we've been able to manage putting heat down here last summer and early fall and extract that heat for very efficient heating throughout last winter. Just wanted to give you a sense to try and get the best detail out of a net zero building. You need to meter and over meter by many standards a building of this size. So we have 3 main meters that handle the production and consumption, and we have a number of sub-meters that are helping us with anything from lab to lab consumption, plug loads in various rooms, some general spaces that we're trying to manage as well. And all that detail will be important for us to understand where our consumption is coming from. We're arranging 3 BTU meters and 3 flow meters for the rainwater harvesting. The rainwater tanks that are out in front of the building, these tanks, there's 2 separate tanks. The total volume for rainwater harvesting capacity is 218,000 liters, and that is used almost exclusively for toilet flushing and some for irrigation, although if you're in anywhere near our earshot here, we haven't needed any irrigation. It's been raining every other day here, so those tanks have been full for most part. But these meters are very important and challenging as well. There's been some challenges in here is making sure that these meters are operating properly. I learned a lot about meters here. I didn't know that much about them. Probably typical of a lot of people. You have a meter at home and somebody reads it and sends you a bill. Here you need to understand how they work and make sure that polarities are correct and that they're commissioned and that they're metering the right detail that you have. And it's amazing what you can learn, some of the errors you can spot in some of this. But for the most part, we've now harnessed that, and we're very happy with what we're seeing. Just before I go back to, some costing here, I just want to touch on the metering piece. I said we're just collecting data right now. We're trying to validate a few things, but early indications are we're actually producing less than our models. Part of that is not surprising if you understand the winter we had here in Hamilton, lots of snow and freezing rain, which kind of baked the solar panels to a little bit. But having said that, solar panels will production over the winter anyways, and we expect that. It can be down as much as 40 or 50% based on a number of factors related to snow and other things. Where we pick up is in the summer months, and that's the logic that you have to have over a year period with a net zero building. And this net zero is really defined as a period over 1 year for the most part, and we're hoping we get on the upside of that curve very soon. Now, having said that, we've consumed less than our models. Part of that is our occupancy is not at 100% yet. We still have a couple labs that weren't at 100% occupancy there. We're just getting into the full scheduling of this. We'll probably have a more robust occupancy this fall. We're doing some research on that with IBM to understand occupancy in the building. But so we're at a point right now where we're comfortable with where we are. We know that as time goes on, coming later this spring and now the summer months, we hope to make that that transition from low production to much higher production. And our consumption, as you can imagine, over the summer is less by default in typical institutional settings. So that's something that we're also counting on, although the building is still well used. It is much less occupied in the summer months. So there's a transition right now. We hope at the end of the day, when we come to our 1 year piece, and we're not talking about just starting last September, it'll be sometime in the fall when our metering data is been validated. We hope to be on the positive side. So we hope to be net positive for people who are interested in that term more so than anything else. And we also are working, as I mentioned earlier, on our zero carbon performance certification. That requires a year of data. We haven't established that start and finish for the year, but that's we're getting that defined very soon. And we hope that we get that certification from the Canada Green Building Council, likely sometime later this year. But it does take scrutiny. It does take some good. If you have staff or resources, whether they're internal or externally hired resources, you do need people to take this on and understand it and track it very. It's amazing how sometimes this stuff can go awry. We've had power failures just like a lot of people. It's amazing what doesn't come on after a power failure and what doesn't work properly after power failures or lightning strikes or surges or whatever. Anything can happen, and it takes a lot of daily due diligence to keep track of these things. I wanted to touch on the final costing. These numbers were very close to what we originally had proposed. There were some changes in there. There were some areas that were fit out a little different. There were 4 labs on the second floor, an additional 4 on the third floor. 7 of those 8 labs, the functional planning of those changed just a few months before occupancy and created some challenges with us changing the curriculum and some of the equipment that was going in there. So that added slightly to the cost, and the area went up just a little bit as well. instead of 90,000, just with the way the functionality came and some of the other requirements that were needed, we ended up just over square feet. But at the end of the day, we were under $500 a square foot. We were originally planned 525. So, you know, there's a number of things that go into costing, and I caution anyone when you're trying to be very specific about any one building for costing. But we went through a little bit of duress here with tendering and fellow projects. S.I.F funding projects that complicated anything from labor availability to material availability and those types of things across the province. In many cases, we're very pleased that we came in at a unit number and a final construction cost that was well within any tolerances. And these are all plus taxes, but we're very, very happy with that outcome. Now, just to give you a sense of another building, to give you a relevance on this, a building that University of Western Ontario put up, what we call, it's their CCC engineering building. It's going to be soon called the Chakma engineering facility. It's a gorgeous facility, very similar demographics. It's roughly $50 million, roughly 100,000 square feet. And the difference there is their unit costs were the same, but they had to, because of their central heating plant and a few other factors of where it was located, needed a conventional mechanical room setup. And their mechanical room, again, similar size building, their mechanical room was almost 3 times the size of ours. And when you build one that size, you fill it with equipment. So they had boilers, they had chillers, they had to have a cooling tower out on the roof and a few other things. Very conventional design, efficient, but conventional, and that added considerably to their costs. So those were costs we didn't have to bear. So net zero buildings can have some huge advantages based almost exclusively on the size of the mechanical room, given the comparison to the gross size of the building. And as well, what we're finding even after almost a year now, the operating cost of these facilities is nominal. We've had virtually no calls for any of the heat pump system or certainly geothermal. We've been told there is no maintenance really on those, other than just watching for leaks and pressure drops, which are very rare. So we're very pleased with this costing. And I wanted to give you a sense now on the next slide. When you look at typical institutional buildings, and the Altus Group provides construction costing data across the country. We reference that. They have a 2019 costing data out, and we're very, very pleased to say that, you know, when you look at a typical teaching lecture hall, assembly can range almost from 400 to 520. And if you have some labs in there, I would say we have some level 1 labs based on the complexity of what's going in there. They can be at a much higher cost. Our unit cost, which we're down right here, fits sweetly right in at the very lower than the lower end of the lab area, and certainly well within the range of the teaching and lecture hall, typical institutional buildings. And we're very pleased with that. So we're, you know, we can say with confidence that this building did not cost any more than a conventional institutional building. There's lots of factors that go with that, including finishes and details, but certainly from a mechanical, electrical point of view, this is an efficient setup that was here, and it helped us with our overall costing. You know, just looking at some of these dates here and some of the challenges, you know, we had a very short, compressed timeline. Part of that had to do with funding agreements from the federal government, and for the most part, we were able to honor those. We were out a few months with a construction finish, but I think everyone was. We had a very difficult, people are familiar with this, a very difficult spring, 2017, which was a lot of rain again. And the construction market created challenges with us for bidding. I mentioned that earlier, but I don't know if I did mention, but even elevators, for example, we only had one bidder for our elevators. Even the company that looked after the elevator systems on our campus was too busy to bid. So Otis was the only bidder. And so it's hard to say if their pricing was right. It was slightly above budget, but their challenge is they had no local resources to handle this. So they had to bring in crews from Toronto, which has other complexities to it. And we also found that with other major sub-trades, there was only, in some cases, only 2 bidders. We prefer 3 as a public sector group, but 3 was a rare experience for us, just with the market that we had. So, and then there's a challenging commissioning process. It's always difficult in any project, but when you really want to make sure about some of the details and other things of how that comes together, particularly with so many meters and other factors, one of the bigger challenges was the building automation system, and how that, our building automation system, which was Delta Controls, now called ESC, and how that system, you know, when you talk to these vendors, they all say they're BACnet compatible, and this can speak to that, and other things. You go to do it in practice, and it's, and I'll use some very plain language, it's a pain in the ass. And you get into some heated discussions, lots of arguments, lots of complications, commissioning nightmares, and everything else. And that's, I'm sure I'm not the only one to experience that, but you'll see more and more of that. I think as we try to get into more sophisticated, very tight buildings, I would call them, from a consumption point of view, the need for very diligent commissioning will be even more so, but that brings in the complexity of more equipment. One of the things we can say here is that we did not introduce any new technologies per se to this building. We're using heat pump systems, which are certainly not new. They were newer in North America. I think Japan and others and parts of Europe have been using them for several decades. But this is probably one of the first times that these systems have been amalgamated together to a larger institutional building to give you a net zero outcome. And we're proud that in our opinion, we've come to a successful conclusion of how that came together. We're just finalizing some commissioning details almost a year later now, but having said that, it's coming together very, very nicely. Metering data is coming in properly now, so we're happy about that. But don't underscore the need for a good commissioning agent that would be necessary for these types of buildings, as any building should have, but there's a little bit more necessity to have accurate data that's coming out of this, and the need to make sure that all things align properly. You know, we are working closely with the Canada Green Building Council on a separate note. One of the challenges that we're experiencing with these buildings, just as I have a couple minutes and I'm winding up with my last few slides here, is there's a significant need to enhance the skill set of trades in the province to ensure that they understand what highly efficient buildings are, net zero buildings, zero carbon buildings. We have some great trades here in the province, but there's enhanced skill sets that they need. And for the newer students coming out, we need to help change the curriculum a bit to make sure they fully understand, you know, what's happening with new installations as buildings are trying to become more ultra efficient. It's not just about putting wires in and putting piping in. You need to understand better how these systems work and how they link together eventually. Just some figures. I know, you know, I've always used a rule of thumb that mechanical electrical costs are roughly a third of the project. Well, here they were, which is a pretty good benchmark. I think anyone who's done a number of buildings will realize that that's pretty fair. And given the technology that we used, which was fairly specific, yet not overly complex, heat pump systems and geothermal wells, I'm pretty happy with this outcome, and you know, we were pleased. And having a mechanical room that's much smaller is a huge plus. And for anyone who's gone into mechanical rooms, I know many of you have, they can be daunting places to go. Lots of equipment, noisy, things running or whatever. You go into a net zero mechanical room with heat pumps and solar thermal and one major air handling unit, fairly quiet. It's actually a pleasure to tour people through there, and I'd probably do a tour a week from different groups, but it's fairly clean. Not fairly, it is clean because there's so few moving parts that need maintenance, and fairly quiet. And LED lighting in mechanical rooms is wonderful. That gives you a nice, bright, friendly atmosphere. So you'll find that that's where a major part of the cost savings is. This isn't 8,000 or 9,000 square feet, which is probably the right size for a building of this size in conventional construction and design. So this is a huge opportunity for many here to consider that you can have a smaller, more efficient, cost-effective from a construction and operating point of view, mechanical, electrical room, and that has huge advantages. So there's a final look at the building. It's taken at night again. It gives you a good sense of where some of the, most of these are glazing areas. You can see this, but other parts are more of the spandrel panels. There's glazing, but there's insulated spandrel panels. So that's helped with the insulating value here. But so far, this has worked out very well. Just to give you a sense as well, this is the student pub right next door. So we had little challenges with construction and security and maintenance on pub nights, which was Thursday night. We had to make sure that we didn't have any accidents happening. And while we were putting this up, this is where that crazy lady climbed the crane in Toronto.
Oh, yeah.
And it took lots of people to pull her down. Yeah, we were a little worried about that. But having said that, our students cooperated. I think everyone enjoyed the process of going through here. And our construction manager, Elliston, did a marvelous job of managing the safety here and the security as well. So I think my timing was reasonably well. We got some time for questions and queries, and I'd be happy to answer any that come up.
All right, so I'm just going to, first of all, unmute everybody here. If I can.
And I'll do my best. If I can't answer something, I'll just make a note and make sure I get back to everybody if I haven't got the answer.
Make sure I've got. All right, if there is any questions, if people could type that into the question function. I think we might have some into.
Yeah, I've got some questions. Thanks very much, Tony. That was this is the second time I've seen it, and it's always a joy to hear what you have covered here. So no particular order. I'll start going. You had talked about the commissioning exercise and how important that was. Can you share with us who you used as a commissioning agent to help out with that, and how did you figure out how to go with whoever you went with?
The commissioning agent, the individual, is John Coco. His company name, I think, is CXP. But John Coco is the name. If you Google that, you'll get the right individual. He did do a different model. Commissioning agents are usually retained as a third party from the owner, often mutually agreed with the architect and the consultants. In this particular case, the architect retained the commissioning agent under their umbrella. And they wanted to do this because they wanted to ensure that there was some autonomy over outcomes, because this was a new building to everybody, right? It was a new style of building, a new net zero building. So we agreed to that principle, but that individual has been outstanding. And part of the issue is making sure that not only as you follow commissioning protocol, quasi-training not only for our staff, but also for some of the technicians that were engaged by the building automation vendor and the vendor as well. There were some learning curves there, and commissioning was very helpful with that.
Question for you. I don't know. Are we muting people? Because I hear some feedback.
We've unmuted people. So if anybody does have.
My horse would have been supposed to be and would not have been hit by her. That's fine, please. I'd like to point out that she was impaired when she was driving. She's impaired now.
Yeah.
Okay.
Okay.
There are some questions.
Oh, good.
Here.
Why don't you
trying to get them up here.
Okay. Let me know when you're ready.
So we've got one comment. Great presentation, and congratulations to Mohawk. My question is, how do we take demonstration projects like this and build the second one and the third one? What is your expectation to get more buildings like this constructed? And how do you assess the interest in this building as encouraging the next one?
Yeah, that's a great question. as how this relates. So one of the things that we were very proud of, we took a bold approach. We targeted net zero at a time when others hadn't done this, and with the right processes in place, we're very grateful that we have an outcome that we're happy with. It needs to be validated, of course, we're doing that. But I think we were able to prove that we're able to do this, that consultants in the industry, architects and sub-consultants, and primarily energy consultants, and I'm proud to say we used a company called RDH consultants for this particular building. They were up to the task. That's the key issue. When we hired the architect and the sub-consultants, we set that target. We're saying we're hiring you for a net zero building, and come prepared. And they were. They took it on at task. We showed that we could do it cost effectively. I believe I demonstrated that in the slides we have. I know all buildings are different, but we certainly can't be too far from anybody trying to take this approach. And I think you'll be pleasantly surprised with finding the same outcomes we had in terms of the mechanical equipment and the size of the mechanical penthouse. What I can say is this, having the in Vancouver last week at the Canada Green Building Council's conference, we had individuals from all over the country, including the U.S., over the continent, U.S. as well, and international, in some cases Europe and China. There's a growing momentum for net zero buildings. Many of the individuals that were there are representing organizations that are either have planned or are currently under design, and in some cases are currently under construction. Mohawk College was one of 16 pilot projects that the Canada Green Building Council had across the country. One of them, called Evolve 1, is up in Waterloo. That's up and running very successfully, a great project. We were second in line, and in terms of getting it up and operating and zero carbon design certification, we're working on the performance, as I mentioned. But all the underway. Alberta's, their University of Calgary is opening up their new building very shortly. So those pilot projects are well underway and will be opening soon. But even around here, many of my colleagues at different colleges and universities are all planning or have started construction on net zero buildings. So, being first out of the gate has a lot and excitement. But I think we encouraged a lot of other fellow institutions in our case to do this. But what I was encouraged about is that the private sector is embracing this as well. They want to have better buildings and better new buildings, of course. Many of them are in the planning stages. The big challenge from a carbon perspective across the country and across the continent is how we retrofit buildings. That's the big horizon coming ahead. Lots of issues related to that. Each building has some uniqueness to it, but between various governance and policies and maybe some code requirements, people are understanding the need to start embracing this a little bit differently. If you get on to either the Canada Green Building Council's website or the World Green Building Council, who were there in Vancouver, we're very encouraged by what we're doing and what we're doing. There's lots of material on those websites that will help you with understanding certainly an urgency, but also some of the detail that's necessary, some of the references that would help you with the decision to go there, including costing, not only our costing, but they've also made some good costing cases for zero carbon and multi-unit residential buildings. So don't hesitate to look into that, but also be encouraged that this is now, there's lots of momentum out there, and I think this will become very commonplace in the next few years.
Okay, so the next question that we've got here, so does the project cost include the PV stations on the adjacent buildings?
Yes, it did. That was something we needed to ensure that we considered. It did not include, in the one case, one building, did not include the re-roofing, but that was something we had planned in our deferred maintenance program anyways. It was just that concurrently we happened to do that. We needed to free up some structural capacity systems, but that was planned. But yes, the PVs were included, and it's hard to. One challenge with the structural piece to this, it's often hard to understand what the unit costs for that were or per watt costs. We're trying to look at some of those metrics right now, but I think all those panels, systems, racking, and everything else, and not the structural supports here, were around $2 million for the 2,000 panels. I mean, I'll refine that. We're looking at that. So it's very difficult sometimes there's costs that cover different labor and materials on different pieces, but that's roughly what it was. But it's certainly all inclusive in that $47 million figure.
Okay, so next question. What challenges, do you have in getting the maintenance and operations people on board? As key in operating to make the most of these features. How did you ensure that those people got on board?
Yeah, a great question. One of the things that's important in any project is to ensure that the vendors that have supplied equipment in there have training to the owner. And in our case, not only myself, but our staff who are very engaged in this particular building. We don't have a large maintenance staff. We don't contract out a great deal, but we have people who are very interested in this and want to learn. So one of the advantages, though, of this is that the heat pump, geothermal and heat pumps and some of the other systems that are in there are not overly complex. They're fairly straightforward. Even in the rain, I'll give an example. Harvesting system, which includes some filtration and disinfection with UV. We were doing some training on that, and the UV light happened to pop on, which meant that there was either a need to change the lamp or something else. And we were able to do the training, and our staff right there changed the UV lamp. They actually didn't have to change it out; they had to just clean it. And so these systems are fairly straightforward, but we have staff who are engaged and want to learn in this. But it's important to correlate the training with your staff, training from the vendors with your particular staff, so you can hand over the building in a straightforward manner.
So I think we'll have one more question to end off, and good one. Okay, no, we'll have two more questions.
And I have a few too.
Okay, we've got time here. So one of the last written question that I'll answer, and then I'll have some verbal questions as well. At the other end of is the college president and board of trustees on the other end of this project. Was there a particular champion that promoted this way of thinking? And what do you think the motivations were for the executive and for the governors to enable this leadership?
Yeah, that's a great question. In early days, as we were contemplating a submission to here, we wanted to differentiate ourselves as a college from all the other applicants. So, all the other applicants were institutions across Canada. In a simple discussion I had with our president, he said, "Tony, what could we do to differentiate ourselves?" And I had no hesitation in saying, "Let's make this a net zero building." He didn't quite understand that at the time, but having said that, it's not a complicated concept to understand, and I said it's a very high standard, and we'll certainly differentiate ourselves. One thing I'm very pleased with is that Mohawk College and its board are very proactive. They like to lead by example, and we do that in our curriculum. We do that with a number of other factors. But as we were getting into a new building, we wanted to be leaders, and that was fully embraced by all levels of the organization. And we're very pleased that the outcome has been successful to date. We're happy that we could champion this in many ways, and you need that champion thinking right from the highest level of the organization. That's my opinion, and we're very pleased that happened at Mohawk College. So, I embrace that with anything, that you need to lead by example, and it's happening right now. So we're happy about that.
My question sort of leads on or builds onto that is, when you did the business case for this, was it done differently than you would a standard construction? Was there other people involved, like higher management level?
Yeah, business cases with institutional buildings are often challenging because we're subject to grants and we're subject to timing and a lot of other things. But having said that, we worked out some straightforward metrics in our application, and that was a size, a cost, and a unit cost for the construction. What we didn't know at the time is what our operating costs would be. I mean, we're getting into something typical, but we didn't quite know that at the time. I think it's even less than what we had expected. But having said that, the business case here made sense to us. One of the challenges that happens is you ask for a certain grant as part of our application. We didn't get quite all we asked for. We asked for almost half the construction cost. We got $20 million. Very pleased with that. But I'll tell you, it was a lot more than many universities. Larger ones, larger universities didn't get $20 million. So there's a lot of complexity in how money is allocated, particularly with a governing body like the federal government, who normally doesn't have a relationship with us. We're creatures of the provincial government, but we developed an excellent relationship with the federal government on this, and we're very happy we did. But the business model was something that often are born out of chance, right? So you need a grant from usually a governing agency like either provincial or federal. You do need private support, and we were very fortunate to get reasonable private support towards the contributions. But certainly the Joyce Family Foundation stepped up immediately. We were very pleased with that and honored that they did that. And you're seeing that philanthropy is a key piece to this, and often is a difficult one to marry into the matrix of a financial plan, because sometimes you get it, sometimes you don't, sometimes you get more than you do. That happens in this business. But we're fortunate, and that's why I wanted to show the numbers before what we planned and after what we planned are very, very close. We pride ourselves, I certainly pride myself, on being as close as possible to that. It's not exact science in this industry, but we certainly weren't way over budget or we're in the weeds on certain things. We're very, very close to where we need to be, and we're proud of that. Certainly unit cost was much less, which was more an important piece to demonstrate that it can be done cost effectively. If you're looking at indices across the country, there's no reason why anyone should doubt that, and I'd be happy to share it.
So just a slight follow-up based on what Tom's saying. As far as in the design, I'm looking at the design thinking, because of all the windows, things of that nature, your energy per square foot is probably somewhat reduced. But do you have a sense of the kilowatt hour per square foot in comparison to benchmarking to other years? For people who are familiar with this term, the energy use intensity here is the design and early operational piece is 72 equivalent kilowatt hours per meter squared. Yeah. For people who are familiar with the term TEDI, thermal demand indices, we're at 19. So now a standard typical university college building could be 250 or 300. So we're a quarter of what that would be. Another reference, if you're familiar with McMaster Engineering Technology building that I was involved in 2007, we opened that up as the first LEED in Ontario. That our new building is runs on 1/5 the power that technology building runs at Mohawk or at McMaster. And it startled me when I saw those matrices. So it's that's a major, that's significant. And then we're very big on culture change and how they can play a role. Because you said that was a big part of the thing that you had to do with your students. What did you factor? What percentage did they play as far as reducing your consumption per square meter?
We know that helps. We're studying that. That's part of my mandate now. I moved facilities now into a bit of a research role based on my background. We need to, and we want to find that out soon. We're going to be working on anything from occupancy to plug loading and those types of things. That information as it comes out, because that's an important piece.
Really important piece.
Plug load, for example, in a very ultra efficient building can be up to 40% of the total load. So you really want to manage it properly.
Wow. I didn't know that. Okay. So I'm certainly, we're going to follow up with you on that, Tony, because that's going to be a really interesting piece, because it's an area of focus that we have with customers that we think is not done or focused on. And when it is, great things happen, and I think basically what you're experiencing is happening there. Is there any other?
I think we've got all of our questions online. We should probably end off in any case, because we're a little bit
otherwise we'll keep Tony here till 5.
Oh, that's okay. That's
all right. I have more questions, but we'll close it off.
All right. Well, without any further ado, I'd like to thank everybody, and I'd like to thank Tony very much for presenting this. I think it was a very informative webinar and good information, I think, for the people that are out there and I think probably considering and wanting to know more about this kind of building. Tony's got his email address up on the screen there, so.
Absolutely. Anyone who has any additional questions and that come up, certainly don't hesitate to email me. If anyone is in close proximity to Hamilton or visiting here soon and like to go through the building, I'd be more than happy to give them a tour. I think you'll learn a lot and be impressed with what you see.
Great. Yeah, I know there was some people that thought this might have actually been an in-person tour initially when this out, so I know that there'd probably be some people that would be interested
Well, we can
in
set
that.
something up. Let's set something up and we'll do that.
Okay,
Yeah,
that would be
perfect.
That would be wonderful.
Excellent. Well, without any further ado, thanks again, everybody, for attending today. We appreciate your time. And like I said, feel free to reach out to Tony if you have any questions or want any, maybe a little bit more information or a tour of the building. And feel free, of course, to reach out to us as well if you have any other questions. So thanks again to everybody, and have a great day.
Julie, one thing I want to mention to
Sure.
this is that this presentation has been recorded.
Yes,
And if people want to get access to this recording,
it will be.
after Mohawk approves it, then, and Tony approves it, then it will be available.
Yeah, that is correct. All right, and with that, we will end off the presentation.
Thank you.
Have a good day, everybody.
Thank you, everyone.
Thanks, Tony.
Thank you.